EOatSEE is a project funded by the European Space Agency that aimed to provide an advanced reconstruction of the relevant processes included in extreme sea level events and its related coastal hazards. This was achieved by a consortium that bring together the EO data provider and the coastal modeling communities to fully exploit the novel capabilities and synergies offered by the latest advances in EO technology. During the initial phase of the project, 80 formal user requirements were gathered from literature review, community consultation, and scientific discussion with experts. Requirements were prioritized considering feasibility and importance aspects, and only those with the highest priority were pursued during the project. A wide range of datasets were produced for each of the 6 EOatSEE pilot sites, covering physical properties of the coastal zone, MAT ocean parameters and modeling solutions, both for the short-term and long-term temporal scales. EOatSEE science approach was based on cascading advanced science tools being applied over the different project pilot areas. 3 major scientific challenges related to extreme sea level events were targeted: predictability, process understanding, and risk and vulnerability assessment. Based on that framework, 13 scientific demonstrators were performed, resulting in 4 technical reports, 5 conferences presentations and 9 scientific manuscripts, with the major work being compiled in a dedicated special issue. Within different pilot sites, satellite altimetry observations were used to validate numerical models. Coupling circulation and waves models allows to detect the influence of waves on extreme sea levels. Another major result from the project is a novel framework to estimate the total water level at the coast from satellite altimetry and other complementary data. Long historical time series were generated for each pilot site, allowing for the decoupling of the different sea level components. This data was used to produce non-stationary extreme value analysis, assessing the changes and impacts on different sea level components. Another application of the coastal water level data was performed within a remote atoll in the Pacific. It was benchmarked for flood risk assessment modeling, which also employed satellite-derived bathymetry and topography. EO-based products were considered suitable for this sort of studies when in situ data is lacking, especially for extreme sea level scenarios. Satellite bathymetry was also derived in Tagus Estuary on Lisbon, where it was able to capture the changes in subtidal bars. Employing this data in process-based modeling demonstrated that such features strongly influence overtopping impacts during an extreme event. With the project coming to an end in early July 2024, a scientific roadmap shall be provided, paving the way for future research and application development. Beyond reviewing the main requirements in EOatSEE, the roadmap shall benefit from community consultation exercises promoted along the project. Among many requests, the need for reliable historical water levels near the coast with a global coverage was highlighted.